Hi everyone, welcome back to my YouTube channel. I hope you are doing extremely well. First of all, if you are new to this channel or haven't subscribed yet, then guys do consider subscribing my channel. It will really motivate me to create more such content for you, and I believe the channel is going to be helpful for you. So you can follow me on other platforms as well. The link is there in the description itself. So let's get started with the problem statement now. The problem says given an array of integers temperatures represent the daily temperatures, return an array answer such that answer I is the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day for which this is possible, keep answer I equal 0 instead, right? So what it says ki we have been given an array of integers, right? Which this array is representing what? The daily temperature. On ith day, what is temperature? Another day, what is temperature? Like that, it is representing temperature. So they are asking us to return an answer array where the ith index of that array is going to represent what? The number of days we have to wait after the ith day to get a warmer temperature. And there could be a possibility that after this specific day, there is no future day for which this scenario is possible, means there was no warmer day. So if that is the case, we have to simply return 0. You get more clarity once we discuss the example. So let's have a look on the example. So here you can see the temperature array consists of this temperature 73, 74, 75, 71, 69, 72, 76, 73, and in the output that's what we are getting. So for 73, if we are talking, so how many days you have to wait to get a warmer temperature? So after 73 we have 74, which is warmer, right? One is matlab, one number, 1 point ahead, let me say in this way, right? So this is warmer, so how many days you have to wait? 1 day. So that's why in the output, see, for this ith position we are getting 1. Then for this particular day, when the temperature is 74, how many days you have to wait? So you can see the next itself is 75. It means again 1 day. So that's what we are getting in the output. Then for 75, how many days you have to wait? So you can see the next is 71, which is lesser. So we won't call it warmer. Then 69 also lesser. Then 72. So what we can say? 2 days we have. Okay. Sorry, 72 it is. No, 72 it is, right? 72 is also lesser than that of 75. Then 76. So how many days we have to wait? 4 days we have to wait to get a warmer temperature. So that's why we are getting 4. Then for 71, if you will see, 69 is not a warmer in comparison to 71. Then 72. So how many days? 2 days we have to wait. So that's what we are getting. For 69, the next day itself is 72, warmer day. So we will put 1 here. Then for 72, the next day itself is 76, which is a warmer day, obviously. So we will put 1 here. Right. Then for 76, you can see here we are having 73. Then this is not a warmer, and then we have gone through the complete array. So in that case, they have already specified what you have to put, 0, right? And for 73, so next to it there is no element or no other temperature that does exist in the array. So obviously for this we have to put 0 only. Right. Similarly, you can just go through this example also. So for 30, if you will see, the next day itself is warmer, so we got 1. For 40, the next day itself 50 is warmer, so we got 1. For 50, the next day itself is warmer, so we got again 1 day. Then for after 60, we don't have, right, anything, so we have to put 0. Right. So I hope now you understand the problem statement, that what exactly the problem says and what is the actual requirement, the thing that we have to do to solve this problem. Now comes that how we'll be solving this problem. Well, while discussing this problem, I believe that the brute force approach that you must have been come up with, that a simple approach, right? What we can do is just pick an ith day, like pick an ith day, and then move ahead in the array and just check the day which is greater than that of the given, or just check, move ahead in the array, or just check that if we get a temperature greater than that of this given ith temperature. For example, if 73 is there, so we will check in the array if there is any temperature which is greater than that of 73. So the next temperature itself we will get 74. So counter would be 1. So we will put that in our resultant array. Similarly, let's say we chose 74. So for 74, now we are checking further in the array if any greater temperature, then we will get 75. Similarly, for 75, when we will pick up 75, so for 75, we will check 71. No, not greater. Counter will be 1, then 69 not greater, counter will be 2, then 72 not greater, counter will be 3, then 76 condition got satisfied, counter will be 4, and we are going to put 4 in the resultant array. So like this, we one by one we will pick the element, and then we will pick that ith value, and then in our array we are going to further check it with other temperatures if they are greater than that of the chosen ith temperature or not. So definitely a brute force approach, right? And like this, if you are going, so what would be the time complexity for this? Approximately big of n square, right? So can we do something better than this? Like if you have solved the problem next greater element, so this is a sort of similarity, the kind of similar problem, that only the only thing is that here we will use the indexes, because we need the differences, right? We need the sort of differences between a given day and the day when we got the warmer temperature. So what is the differences between the index, right? So again, for solving this problem, we will use stack data structure, right? And this time what we are going to put, see, it's all about the indexes, it's all about the game of the indexes and the differences that we do need. So we are going to put that index in our stack. We are going to put that index in our stack. So let's discuss it more clearly to get a better understanding. So let's have a look. Now what we will do, instead of having, we will start our iteration from the end. We will start our iteration from the end, right, from right towards left. I said we will use a stack here, and what we are going to put in that stack is the index. Okay. So yeah, first what we have seen is, and let me make this output array also, or let me just use this one: 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. The first element you have seen is 73. So right now, for you always know that for the rightmost element, every time there would be no further element to do the comparison or to check, right? So every time the value would be 0. Right, so as of now our stack is empty, put it as it is, and I value we will initialize obviously from n minus 1. No operation has to be performed for this one, because this is the lastmost element, right? So I value will proceed ahead towards it. So now, sorry, so here we are not obviously going to put the element, but the index. So 7 is going to be kept here, right? Right. So yeah, now I is pointing to this 76. So what our expectation is that, see, for example, 76 is here. Let's say if here was 78, right? So we can say that, okay, there is one, after it we got one element, no, which is warmer day, we can say we have got, but as of now there is what? There was what? I think 73 was, right? 73 was there. So we will do this check only, we will do the comparison that the ith element, first of all, we have to make sure that the stack is not empty. So stack is not empty, and the ith element which is on the top of the stack, what is that? 73 is there, right? 73 is there on the top of the stack, right? So we are going to do the comparison. So 76 is obviously what? 76 is obviously greater than that of 73, right? So what we will do? So this is not satisfying our requirement. So what we will do? We will just pop it out. We will just remove it. We will just remove it. We will just remove it. We will just pop it out. Okay. And now, as if we didn't got anything, so here also the value will remain, that is 0 only, because by default all the elements are initialized by 0 in Java, right? So 6, so now I value will be decremented, and now I will be pointing to this 5, and this also, this index we are going to push into our stack 6. Now 72 is now the value which is there at this index, what is 72, and the value at index which is there on the top of the stack 672 is smaller than that of 76, right? So we can say we got a warmer temperature. Now if you have got the warmer temperature, so what is the difference between the two indexes? That's what is going to, it is going to show, okay, after how many days we got the warmer temperature. So 6 minus 5, we are going to get 1, and that's what we are going to put in our resultant ith array. So here we put 1. Then we will proceed ahead. I is pointing to this 4 now. Again, we are going to check. Also this will be pushed, this 5 will be pushed, so push 5, right? So 69, what is the element is fourth index of array 69, and at the top of the stack at the fifth index we have 72. So again 69 is smaller than that of 72, means what, that we got a warmer temperature, right? So what is the differences between the index 5 and what is like the element or the index that is on the top of the stack 5, and the I is pointing to 4, 5 minus 4, 1. So 1 we are going to store in our array, and this 4 is going to be pushed into the stack. Then I will be proceeded ahead. Now this time we have 71. 71 being compared with the element at the fourth index, which is 69. So 71 is greater, so we are going to pop it out because it's of no use, right? 71 is greater than. Then next we have element at fifth index, which is nothing but 72. So yes, we got a warmer temperature. So now what is the difference? So 5 and 71 is 3. So 5 minus 3, 2 is going to be stored in our resultant array. And this 71 index we are going to push into our stack, which is 3, right? Now I will be pointing to this second index, right? So what is the element at the second index? 75. And the element at third index, 71. So 71 is lesser than that of 75, right? So we are going to pop this. Next we have this 5. So what is the element at the fifth index? 72. And I is pointing to what? 75. So 75 is greater than 72. So this is also not a warmer element. Now next in the stack we do have 6. So 6, the element at the sixth index is what? 76. And right now the current element in consideration is 75. So yeah, condition got satisfied. We got a warmer temperature. So if you will see the difference, what is the difference? So 6 minus 2, 4. So 4 we are going to put in our resultant array, right? And then we are going to push this second index to our stack, and I value is going to be this 74. It is going to point to 74. Now we will check for this. So 74 and the top of the stack we do have 2. So what is the element at second index? 75. So 74 is obviously lesser than that of 75, means a warmer temperature. What is the difference between the two indexes? 2 minus 1, 1, right? So 1 we are going to keep in our array, and then we are going to push this index 1 also in our stack. Then I value will be decremented. We will come to 73. Then 73 is obviously is also what, lesser than that of 74. Then again we got a warmer temperature, right? So 1 minus 0, 1, and what I is pointing to 0. 1 minus 0 is what? 1. So 1 is going to be stored in our output array. So we have gone through all the elements. So yes, we got our resultant array. Now if talking about the time complexity for this approach, so only once we have gone through all the elements of the array, so big O of n, and as if you have used the extra space here, this stack, so space complexity big O of n, right? So yeah, that's it from my end. Thank you so much for watching this video. But one thing I missed here is that the code part. So let's have a look on the code part. But I believe that if you have understood the approach, right? So I would say understood the approach, do the implementation by yourself. If not, then just have a look on the code part as well. So here you can see the length of the temperature we have stored in n, the resultant array that we are going to return, and the stack as I've discussed we need for this for this problem. So we have started our iteration from the right side. So for int I equal to n minus 1, I greater than equal to 0, I minus minus. So first thing is that if our stack is not empty and whatever element, ith element is there, and it is what? It is greater than, for example, here what the scenario was, let's say on the top of the stack we do have the index of 69, and right now I is pointing to 71. So obviously 71 is greater than that of 69, right? So greater than or equal to that of the element, the index. So st dot peak is going to give us what? Index, right? So if it is greater than that, so what this index is of no use, right? Because it is not going to give us the warmer temperature. So just pop it out. So this popping operation we are doing here, right? Now in this if condition we are checking that if our stack is not empty and the temperature, ith temperature is lesser than, right? Means the temperature or the index that we have on top of the stack, it is having a greater temperature or a warmer temperature, right? So if that is the case, so yeah, but this is what we are looking for, right? So we will get into this and we will update our resultant of is st dot peak, the index that is there on the stack, subtracted by the ith index, right? So that's what we are doing. And yes, we are pushing the ith index to our stack, and at the end we are returning the result array, right? So yeah, that was the code for the approach that we discussed. So yeah, thank you so much for watching, everyone. Bye bye.